Hey guys, today we're going to talk about naming simple ionic bonds. So let's go ahead and pick up where we left off. We're going to start first by talking about how to form a neutral compound. So we've got three problems. This one right over here, this guy over here, and then this one down below. For each one of these, what I want you guys to do is figure out we got a positive charge and a minus charge. Think how many of each are we going to need so that they cancel out and form a neutral ionic compound. Pause the video if you need more time. Here we go. Okay, so for the first one, we have Fe3 plus and Cl1 minus. So what we're going to end up doing here is we'll have FeCl3. That means we have three 1 minuses, and we have one 3 plus. That means we've got a total of positive 3 and a total of negative 3 on the other side with the 3 Cls. Over here, we have Zn2 plus and N3 minus. That becomes, we need 3 of the Zns with the little 3 over here, and 2 of the Ns with the little N2 there. What you'll notice for these first two is pretty much what happened is we just took the numbers on the charges and kind of switched them. So there's kind of a crisscross going on here. That works most of the time. You'll also notice with Fe and Cl, it's kind of like we switched the 1, saying that there's 1 Fe, and we switched the 3 with Cl, kind of like there's 3 Cls. That works most of the time. You just kind of take the numbers and then, or the charges, and then switch those numbers, and that becomes the amounts of each one. It doesn't work for the last one here, W6 plus S2 minus, because for that one, we need 3 of these S's and just 1 of these W's. That gives us 6 minuses from the S's and 6 plus from the 1W. So we used to teach that as like a method of like crisscrossing the numbers. We don't anymore. Instead, how I want you to think about it is think about, okay, this 3 means I have 3 of these 2 minuses. So 2 minus, 4 minus, 6 minus. And then think of the 6 plus just as 6 plus. So they have to be even, they have to balance out. So these are examples of formulas for ionic compounds. What we're going to talk about today is how to name those formulas. So one other thing to remember, I'm going to use the phrase anion to talk about negatively charged ions, and I'm going to use the phrase cation to talk about positively charged ions. That's still true from yesterday. Cool. So one of the things you might remember from the other day is charges. So these tend to be the charges that different ions have. Everything in the first column tend to form a 1 plus charge. Everything in that second column tend to form a 2 plus charge. Everything in that third column tends to form a 3 plus charge. It starts getting kind of tricky because everything in that 14th column doesn't really tend to form ions. Everything in column 5 tends to have a 3 minus charge. In column 6 or 16 has a 2 minus charge. In column 17 has a 1 minus charge. And in column 18 they don't have a charge. They tend to have a charge of 0. These are generally true. If you want to know specifically what an atom has for a charge, you're going to have to look at the back of the periodic table. These positive charges are only true for the metals. So for example, boron doesn't really have a charge of 3 plus, but aluminum, gallium, indium, and thallium all have charges of 3 plus, but some of them do get a little bit weird as you get towards the bottom of the periodic table over here. The 3 minus, 2 minus, and 1 minus is only true for the nonmetals here, so that's not including the metalloids. The 1 plus and 2 plus is pretty much true for everything. But yeah, so if you're more concerned about what the exact charge of something is, you can always look on the back of the periodic table, and there's a huge ion list that kind of tells you what every single charge is. Okay, so today we're talking about just naming basic binary ionic compounds. Binary means you have 2 types of elements, meaning you have a metal and a nonmetal. So here you'll see Na in blue, Cl in red. That's an example of a metal and a nonmetal coming together. Na has a charge of 1 plus, Cl has a charge of 1 minus. How we name this is the first thing we name is we name the cation's name. So we just say what the name is. Pretty straightforward. And then how we name the anion, the red part here, is we name the nonmetal and then we switch the ending. Usually most nonmetals will end in "ine." We switch that to IDE. So how we would name something like NaCl is we take Na's name, which is just sodium, and then we take Cl's name and then switch the ending to "ide." So Cl is called chlorine, but what we would do is we would switch the "ine," so it's chloride. So to name an ionic compound NaCl, it's not sodium chlorine, it's sodium chloride. And that's how we name binary ionic compounds. We just name the cation and then we name the anion and switch the ending so that it has an IDE ending to it. Notice here that the metal in the formula is always going to come first. So the metal in the name always comes first. We always say the metal's name before we say the nonmetal's name. We always say the cation's name before we say the anion's name, if that makes sense. Okay, now a couple of tricky nonmetal names: nitrogen, oxygen, phosphorus, sulfur, and selenium. You might notice something that's true about all four of these nonmetals. They don't end in INE. So remember, the rule with nonmetals is you have to change the ending so that it ends in IDE. So I want you to write these down. Nitrogen becomes nitride. Oxygen becomes oxide. Phosphorus becomes phosphide, not phosphoride, just phosphide. Sulfur becomes sulfide, and selenium becomes selenide. So it's definitely helpful to write these down just so you know where the IDE comes in and how much of the name it gets rid of. There's no real pattern here, so you're just going to kind of have to know these. And after a while, these will just start to sound correct. You might have heard of oxide before, like carbon dioxide. So maybe some of these sound familiar to you just from being an English speaker. Okay, what I'd like you guys to do now is go ahead and work on naming these compounds. We'll go ahead and do the first one together. MgS. Mg stands for magnesium, and S stands for sulfur. So it's not magnesium sulfur, it would be magnesium sulfide. Great, that's the first one. Go ahead and try out these next couple. Hopefully you've got aluminum fluoride, calcium iodide, beryllium bromide, and barium nitride were what you got for the other guys. Great. Hopefully now you have an idea of how to take a formula and convert it into a name. What we're going to talk about now is how to take a name and convert it to a formula, which is a bit more tricky, because what you'll notice here is that some of these formulas have numbers next to them, and some of these formulas do not have numbers next to them, but nowhere in the name do we have any numbers. Just like before, how we figured out whether stuff had numbers here or not is going to be based on the charges, right? These are all neutral compounds. And the only way we know kind of how many sub numbers to put in the subscripts here is going to be based on these compounds' charges. So if I'm given a name, what I'm going to have to do is I'm going to have to find magnesium, look it up, and figure out what is its charge. Then I'll have to find sulfur, look it up, figure out what its charge is, and then once we have the charges of those two atoms, then go ahead and form a neutral compound, just like we've done previously. So when we're going from formula to name, all we have to do is just say the name of the cation, say the name of the anion. When we're going from name to formula, we're going to have to find charges and then make them neutral. Okay, so let's say we have something like barium nitride. Barium nitride has a formula of Ba3N2, but how did I get that formula? Let's talk about it. Okay, so the first thing we know is we know that barium has a 3 next to it, so that means I have 3 barium atoms. Boom, 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 just like that. And then if I see a 2 here, that means I have 2 nitrogen atoms. So this is just something that's true about the formula. That's what the formula means. Now, what you'll notice is if you look on the periodic table, barium has a charge of 2+. And you can find that by looking on the back of the periodic table next to the ion list. You can find that just by looking at the front of the periodic table. It's in that second column. So barium has a charge of 2 plus, 2 plus, 2 plus. My total positive charge here is 2 plus 4 plus 6. And then nitrogen has a charge of -3. So that's where I get my -6 from. They cancel out. They form a neutral salt. So what you'll notice here is kind of, again, how I was saying that the numbers kind of switch spots. Now keep in mind, we wouldn't know the 3 and the 2 to start, but we would know the 2 plus and the 3 minus to start. Notice here the metal always comes first. Here are two things that I want you to write down. Subscripts, these are numbers like 1, 2, 3, 4 that are kind of below. They mean numbers of atoms. So how many atoms do you have? If you see a 3 as a subscript, that means you have 3 atoms. Superscripts, 1 plus, 1 minus, or 2 plus or 2 minus, that means charges. Notice that they always have a plus or a minus next to them, and that's going to talk about for one specific atom what a charge is. So you can have one barium atom that has a charge of 3 or 2 plus, for example. But then in the formula, you might have 3 barium atoms. So your total charge of all 3 barium atoms would be 6 plus, if that makes sense. And that's just kind of what these things are saying here. Charges are never included in a formula. That's another important thing to write down here. You never put charges in kind of your final answer of your formula. This is just kind of a funny meme. Okay, so let's talk about formula writing here. Let's say we have something like calcium fluoride. What you're going to have to do first is you're going to have to look on the periodic table and figure out what calcium's charge is. Calcium is, it's abbreviated Ca, and it has a charge of 2 plus. Fluorine is F, and it has a charge of 1 minus. So now that we have the 2 plus and the 1 minus, we know that we're going to need 2 1 minuses to equal out 1 2 plus here. So we're going to need another F with another 1 minus. That gets me -2 on this side and keeps my 2 plus on that side. So my formula is going to be CaF2. Go ahead and try out sodium iodide and aluminum phosphide. Pause the video when you need more time. Sodium iodide, sodium is 1 plus, iodide is 1 minus. So the formula here, there's no numbers, it's just Na. For aluminum phosphide, aluminum is 3 plus, phosphorus is 3 minus. So if you wrote down Al3P3, that is wrong. What we would just want you to write down is ALP, just because you need 1 Al and 1 P. It's kind of like fractions where you wouldn't write 2/4 when you could just write 1/2 as your final answer. So please make sure that whenever you do this, the numbers you use here are the most reduced. In this case, 1 and 1, not 3 and 3. Great. Okay, so for name to formula, the first thing we have to do is you have to write the cation's, the symbol. So for example, for barium, it's Ba2 plus. Then what you want to do is you want to write down the anion's nonmetal's ionic symbol, which is 3 minus. Once you have those charges, the 2 plus and the 3 minus, then you want to figure out, okay, how many of each do I need? So then one of the ways to do is crisscross the charges. Another way is just to kind of add them up so that they're even. We've done this third step here before. Yeah. So you get a final answer of Ba3N2. Hopefully this helps here. One of the things you'll see here is what I said is the best way to learn is to practice a lot. That is true. So what I've got for you tonight is some homework on this stuff. And hopefully as you're practicing it, it makes a little bit more sense how to transform from formula to name from formula. That's all for today, guys. Thanks you so much for listening. I hope you have a great rest of your day. Goodbye.